Good morning, everyone.
Good morning.
Love to see everyone, brothers and sisters. So today, what I'm trying to do in this 45 minutes, I will try to keep things simple and at the same time give you some insights. So at the end of the session, we will have another few days to go. I love to answer more questions. And if you have any questions, we can zoom deep into the solutions. So first one, I will talk about the overview and importance of blockchain technology. So this is me when I was slimmer. I am a book author. I wrote 2 books. 2 of them are kind of best-selling. First one is in Korean. The second one I sold over 10,000 copies. So it's still selling. I'm known in the space to give government advice on cryptocurrency matters, regulations, and so forth. So I'm one of the earlier enthusiasts, who talk to the government and let them understand what exactly blockchain is like. So when I started this journey in 2017, a lot of governments and ministries do not understand what I'm trying to say. But right now in 2023, many things are very fast. So quickly, I'm also part of the NPO in Mongolia. I look after digitization. I'm also an advisor to Bybit. Bybit is the 3rd largest crypto exchange in the world right now. We trade more than $10 billion a day. I'm also a former advisory board member to Hyundai, the famous Korean car brand. I look after things like blockchain implementation, advisory, and so forth. I'm also a wannabe academic, so I have a PhD in productivity science. I give a lot of lectures in different parts of the world. So this is my book number 1 bestseller in South Korea. This is my second book. It's about NFTs. So NFTs are really fun, easy for everyone to understand. Like I mentioned right at the beginning, I just want to keep it really simple. So it's keep it simple and smart. The last word is not a good word. They use. So I just want to keep it really smart and just get everyone to understand what we are trying to do here. So let's cover the basics of blockchain technology. Quick introduction. What is blockchain? So to me, blockchain is a decentralized, distributed ledger that securely records and verifies transactions across multiple participants. It sounds like a really big term, So if you talk to a lot of other maybe blockchain experts, or if you talk to other blockchain practitioners, they'll make it really complicated. But trust me, blockchain technology is really easy to grasp. It's very easy to understand. So the architecture underlying framework, would be the technology itself. Let me just quickly go through some of the terms that we use normally. So if you look at the screen right now, we talk about blocks, right? So data structure, data in the blockchain is structured into blocks. And then all the transactions and informations are stored on the block. And there will be a unique identifier. The identifier is called a hash, and that is like a fingerprint. Next term that you often hear will be hashing, hash. So hash is a process where data from the block is converted into a fixed length of strings of characters. So it's kind of straightforward. Then there will be a chain structure where the hash of each block is included in the subsequent block. I'll show you a diagram later on that can help you relate a lot better. Then you will hear about consensus mechanism, because blockchain is all about consensus, letting everybody agree, everyone disagree. So that's a method of achieving a certain level of agreement between the participants. You know, it could be someone from Turkey, it could be someone from Japan. You know, that's how you create a certain level of consensus. And there are many different kinds of consensus. There's POW, there's POS, and the list goes on. The more popular ones are POW, which is proof of work, and then POS is proof of stake. In the later part of the workshop and the whole presentation, I will touch on more detail. So, a lot of these terms that we are talking about right now, they are all peer-to-peer, right? And through the consensus and validation, nodes communicate with each other and agree on a certain task or a certain validation. So validation is a big word within the blockchain space. You know, if you are dealing with data, you need to validate. You need to make sure that the data is worthy, the integrity is there. So this is a not so straightforward a diagram. You know, it goes through a few stages, but it is very easy to understand. You know, so you look at number one, you request for a transaction. Then a block that represents the whole transaction is created, very straightforward. Then the block is sent to every node in the network. Then people start to validate. You know, using different consensus mechanisms, they start to validate. The nodes then receive a certain reward because you are working. You know, everybody is working. And if you are working, you get a reward. I think that is fair. Once this is proof, the block is added to the existing blockchain. After going through the whole process, all the validation and so forth, it will go to the number 6. Number 6 is the transaction is completed. So these then help you to somewhat assure that people agree to the decision and the transaction is flowed throughout the whole process. Again, the slides will be made available to everybody. You can take a look. Then if you look at the structure of blockchain, again, a lot of different experts will tell you many big words and so forth, how you can do that, how you cannot do that. But if you look at this structure is very straightforward. So you look at right here, there'll be a block 1, you can see the header, you can see block 2, block 3. These are how the blockchain structure is going to be like. There's no need for you to understand how the structure is going to be like, to be very honest, but if you know the concept, it can be reapplied in many different scenarios. So this is how the whole structure and how the hash function is going to be like. Even simpler, you know, this very simple picture that I've created is very straightforward. So you can see hash in the first block, and you can see the previous hash in the first block. So this part is very straightforward. Yeah. Then if you look at the second block, part of the information is being brought to the second block. So as you can see, previous hash data is actually now captured on the second block. Same thing for the third block, the previous hash data is being captured. This creates a chain effect, and this then creates a chain of blocks, and each block will then have the same set of data. This will flow throughout the whole process. So now if you want, let's define what are the core principles again, right? So these are the things that we really need to take note of, and these terms will be used in many different scenarios, and it will be used again and again in the whole workshop. So first one, decentralized. So when we look at blockchain technology, we often mention about the word decentralization because we felt that if there's no central authority controlling the entire system, you know, it is more resistant to different faults, different issues and so forth. But of course, we are talking about a governmental setup right now. So I will give you different solutions when we move forward, you know. So decentralization, just keep it at the back of your mind, all right? Transparency, so all the records will be made available online, on-chain. if you choose to make it available. All right, and if you choose to make this available, everyone else who are on the same chain, who understand the whole process, will be able to see the information that you want people to see. All right, so there's a level of transparency. For example, how you collect your data, right? Most people will just give you a number, but if you put the whole process on the blockchain, you can then understand how the chain of data are being collected. Security, I think blockchain is very secure, to be very honest. Of course, you will see many news articles saying that, oh, there's a hack going on and so forth. But that kind of a vulnerability actually lies in the applications that were built on top of the blockchain. So Ethereum, for example, public blockchain, it has been good so far. All right. So if you talk about security, if you talk about blockchain, these are all very closely linked. Immutability. So once the transaction is being recorded onto the blockchain, literally it is very difficult for you to change it or delete it. But of course, our good friend we have mentioned, what if the whole blockchain there's only 2 people using it? So you just need to change that too. So that is another story for another day. But if you do this in a larger capacity across different ministries, countries, changing the records is almost impossible. Consensus mechanism, this is another term that I mentioned just now. It is extremely important, right? It is how you make a decision. So you think about it in that manner. Smart contracts are agreement on top of the blockchain. They will be helping you to enforce some terms and conditions. So a lot of the things that you are trying to do will be somewhat automated if you understand the whole process. Privacy is not a strange word, stranger to any of us right here. Blockchain do offer a level of privacy if you set it in the right manner. So there's no single point of failure. Since there's no central authority, you will not see such a fault in the whole process. Like I mentioned, there's always an increase in security. You can definitely read through all the words that I will share with all of you. Tampering of the data will be minimum. You will eliminate a lot of intermediaries. Again, in the data perspective, if you eliminate a lot of this intermediary, and if you run the whole process using a blockchain, then a lot of this data integrity will be very high, because there's no way that anyone can change the data or alter some of the data, before it reaches the final moment, on your server. And we look a lot at the consensus again, but what we are trying to do so far, what we are trying to preach is all about distributed consensus. All the validation are all distributed. Nodes that are reliable will remain. Nodes that are not reliable, they will be removed. So all this whole process will be 100% distributed. So again, in a decentralized blockchain, consensus is achieved through algorithms, POW, POS. And this algorithm requires the participant to actively collect the data, agree on the data, and then include in the data. So, as I mentioned just now about the consensus mechanism, POW is algorithm used by Bitcoin. They solve a complex mathematics puzzle, require a significant amount of power, and then they reward the participant on the state of the blockchain. So the other one will be proof of stake. That is just to validate the stake ownership. They then work towards the same goal, of creating a more transparent, a more agreeable consensus mechanism. But it is also known that they consume less energy as compared to the POW mechanism. Other algorithm, there's DPoS, just for your information. There's a PBFT as well, but these are not the most commonly used consensus mechanism. The list goes on. And in fact, there are many different kinds of consensus mechanism that will be more suited for your organization. So let's not be worried about what to use, how to use, and so forth. Because right now we are just talking about the most basic, most fundamental things that we are trying to solve right now. So these are some of the really basic examples. It depends on how you want, what kind of scalability you are looking at, what kind of energy efficiency you are looking at. These are some of the things that government really look at. Some of them, they want to have a more energy efficient blockchain, so they might choose one over another. Some of them, they want more flexibility, they will also choose one over another. So these are all choices. So after today, in Turkey, for example, there are a lot of blockchain experts that come to you and ask you about a lot of different questions. You can then ask them back, what are you talking about? This is what we want. And then they might come up with more things that can customize to your needs. Consensus involves the following step. So there's a whole transaction process where all the nodes, they just propagated, they're all their nodes. Then there will be a validation process, and then there will be a block creation process. So this whole process seems to be reasonable, to be very honest, but the whole process goes back to the same picture that I've shown you with the 3 blocks. The main concept remains the same. If you look at it, we talk about consensus mechanism, and then at the end, we talk about the block confirmation. I'm trying to let everyone understand that this whole process is not rocket science, right? You will be shown many different times the same thing, but the concept never change. You got to remember this, the concept will never change. So through a distributed consensus, blockchain network achieved a shared and trustless agreement. And this is the kind of outcome that we hope to achieve. Whether or not you are collecting data from the public, you are collecting the data from the universities. These are things that will give you a good fundamental to how the whole process is going to be like. You also enable participants to validate and trust a transaction recorded on the blockchain without the need of any centralized authority. You might be thinking, hey, what's Andy talking about? We are government, it's somewhat centralized. But collection of data, there's no need to be centralized. It can be done by an algorithm, right? At the end, government organization collect the data, they can then analyze the data. But this process will help the government organization to have better data sets. And with the better data sets, you can give more accurate reports, and the reports that people want, right? People want to hear and see the real reports. That blockchain technology will give you the extra validation. Then again, there will be private blockchains and public blockchain. So far, what we have talked about are mainly public blockchain. But again, the kind of concept will not change. So public, they are open and permissionless. You know about Bitcoin, you know about Ethereum. Any one of you? Bitcoin, Ethereum? Okay, looks like it's not a big stranger to everybody. So to be very honest, most people look at the Bitcoin and Ethereum from a more cryptocurrency perspective. They talk about, oh, Bitcoin is going to be 31,000, 35,000. No. Those are just for speculation. Of course, we all love to look at the price, but the technology behind it are actually the key, right? So these are public, open, and permissionless. Advantage of a public is decentralized, it's transparent, it has high security. Because if it's public, there are many nodes. There are many people holding on, making a decision, trying to build a certain consensus, around some decisions. This is how it is. All right. Limitation, scalability, and there's a little bit of issue with transparency. Again, like I've mentioned, it depends on how you put forward your solution, what you want people to see. If the set of data that you want people to see is not properly thought through, of course, everything will be disclosed. Use cases, I will talk about use cases a lot, at the later part, because I felt that use cases are very important. That gives you a sense of visualization on what the rest of the world is trying to do, and how you can reapply that concept within the whole EIS ecosystem, right? So use cases, you can see a lot of public blockchain, they use that, DApps. They provide a certain level of usability on top of the blockchain. Keeping things simple, the next one will be private blockchain. You might have heard of Hyperledger or this Coda. These are all very enterprise level blockchain. It is widely known, in the financial industry. Not a stranger. These are all run by big brands. I'm not going to mention who they are. Run by big brands. Yeah. Advantage is the whole process is kind of some selective access. Right? Not everyone will have the permission to be on the chain. Right? Efficiency. You can create very high speed. We had this conversation yesterday about high speed, about managing 7 terabytes of data. So if you are on a private blockchain, this thing can be done. It's very efficient. All right? And there's an enhanced privacy because indirectly, this is controlled by you, and you. So you are the one who set the rules. Limitation, centralized. Right? So please do not misunderstood that blockchain got to be centralized or got to be decentralized. It can be a hybrid, right? It can be during the collection phase is decentralized because you want to tell your people, people supporting the government that this whole process is decentralized. I have no control. You tell us the truth, we don't know who you are. That's actually true. But then when it comes back, it can then fall into a different category where you can dissect, look at the data in a lot deeper manner, right? And then there's a reduced network security because, again, the talks that we had, if there's only 2 people, 2 nodes, the security is just between the two person, So either you kidnap one of them, then get control of the whole network easily. Use cases, well, you can see a lot of private companies are really using that. It could be from a bank perspective, it can be from a supply chain perspective. I know of listed companies, supply chain, they use a private blockchain to actually facilitate their whole process internally using a private blockchain. Again, I like to always give you different tables, table charts, and so forth. This, at a glance, you will see the 4 different kinds of blockchain: public, private, hybrid, consortium. The different advantages, disadvantages, and the use cases. Right? So going for public, we have talked about it many times. Use cases, cryptocurrency, document validation. Like I mentioned in the consultation yesterday, certificate schools, they use such a technology to verify whether your degree is real or your degree is fake. these are normally through a public blockchain. If it's private, like I mentioned, supply chain, asset ownership, fairly suitable for government. I know one of the Southeast Asian ministry, they use a private blockchain to verify all the title deeds of the house. Your house, your property, and so forth. They use a private blockchain. Hybrid, I will just quickly touch on. It's just like the word hybrid. It's a best of both worlds, right? This kind of a hybrid blockchain is usually used in places like medical field, some real estate, management of real estates, because you need both of them just to make things work. And then the consortium is, again, you can see them in banks, you can see them in research organizations. I personally see them more in the research organization because the level of control is actually very high, But I would just love to stick with public and private for the time being. How you're going to mix and match, it really depends on your engineer and how the whole structure of your system is going to be like. So again, these are things that I inject into your brain. You will then later on come up with some scenario. We can break up into groups. Then you can come up with some scenario later on to make sure that you understand and you apply to it. It's up to your imagination. So this is something that I wrote, understanding the differences and use cases of public and private blockchain is crucial. And this thing is very much customized to your industry. Do not be fixated to what you want. Always look at the end result that you want. If the end result that you want is something that is towards the nature of more decentralization, or you treasure security over all other aspects, then you can use this chart to make some assessment on how you are going to operate. Importance of blockchain technology in various industries. Finance. So right now you can see banks, Singapore, there are also banks who are using blockchain technology. They can do clearance of your funds 24/7, right? So it used to be just during the operation hours, but with blockchain, with the application of a smart contract, you can literally operate 24/7. That's really good, right? Remittance can be done anytime, instantly. You can see a lot of cross-border finance transaction. You see a lot of remittance. These are all real use cases that have already been in the space. The earliest one that I understand would be maybe about 6 years ago. So these are not things that are just coming out today. Use cases proven are all there. The kind of a transaction volume that they manage through the blockchain system, these facts and these numbers are all also factual because these are all 2022 data. I think the success story would be Ripple XRP. So they partner with many different banks to make sure that they bring out the right narrative on how crypto payment or how funds can be transferred from one country to another country with low or little cost, or maybe sometimes even free, from one country to another country and in a very fast manner. It's not like, it's going to take like a TT, telegraphic transfer, it's going to take a long time. No, it's almost immediately, Supply chain, definitely something really big. So for those who want to find out more about supply chain, there are also states or provinces, in the world that have really put the supply chain on blockchain and on a long-term pilot trial. Because actually, from a more ministry standpoint, or a more province standpoint, it is actually very easy to implement this. But the people on the ground are not that tech savvy. So in other words, the supply chain narrative is already there. They can track and trace the food. They can track and trace your BL. They can track and trace your products. There's a lot of things that can be done. This is also a very big thing for medical companies or pharmaceutical companies. There's a lot of fake medicine in the space, and if you put your products on chain, you can actually verify them instantaneously and without too much of a hassle. Because if you go by the old method where you just use the barcode and nothing is actually on the blockchain, people can just change it, right? But if you put your birth certificate on the blockchain, as you know, you can't change it, so it's always there. I mentioned about traceability, right? About food safety standards, how you can verify your origin. These are things that, again, 100% in the market with proper solution and proper way of collecting the data. I think success story would be Walmart partnering with IBM. They improve the speed of tracking. They reduce possible food contamination. And if there's a food contamination, they reduce the time to draw all the food back. Because actually all these things are all traceable. Where they go, who end up having the product, all these things can be done. And in fact, if you run this properly, it can also be maybe changed and convert into a more royalty program. You just imagine you buy a beauty product, right? You can scan it using your own phone. You can get data, you can get birth certificate, you feel a lot better. Also at the same time, they can give you a certain reward. So this is a win-win-win solution. Healthcare, medical records, these are all very straightforward utility for blockchain. As you know, health record, EHR are very popular, right? But there's also a lot of issues with security, privacy, and so forth. My Prime Minister's data in Singapore was being hacked as well. So healthcare is actually very important, right? So if you can use healthcare, add in the blockchain technology on it, it is actually a big beauty. There's a lot of things that can be done, clinical trial, medical records. The medical records is the best. Right now, a lot of the medical records are being kept in private, or they are not shared among doctors. With the blockchain technology, you can be empowered to own your own medical record. And if you go and see Dr. A, you give him access to your record, right? And then you see that Dr. A is giving you things that are a bit strange, right? You go to Dr. B, right now you can do that too, but then you go to Dr. B will demand you to do a blood test, do more MRI and things like that. But if all your records are on chain, you can go to the second doctor, open up the whole process, open up the data, let them see. You will save time and you will save more money. And the power of owning your own health records are actually priceless. So success story, there's a medical chain, a blockchain-based platform. They let you control their medical records. And this is a really good business, for the private sector, and it's also a very good implementation for the public healthcare system as well. Government, always exploring, looking at blockchain technology in a very different manner. Again, it can be a hybrid. It can be talking about a database system, or maybe your current context, which is part of the EIS. Or if you don't look at it too deeply, you can use it as a welfare, aid, charity kind of a function. So if you look at it, government use it in a few ways. One would be a decentralized identity. So some of the countries are really using that. They use the blockchain to streamline KYC processes for the government together with the bank. So these are things how the bank and the government are working together. Success story, I think, would be Estonia. So they have launched an e-residency program, and all the blockchain, all of these are blockchain documents that you sign, your ID, everything's on chain. So today, if your name is Andy, your name will be Andy. You can't just change it anyhow because everything is on chain. Again, some words from me. So as the technology continues to evolve, it is expected to drive further innovation, transformation, and revolutionizing how industry operates in the digital age. We are now not just constrained, with the people locally. You are also talking to people across the world. You are talking to different technology and product that are made available everywhere. So what I'm trying to tell you is that you should try to put your energy to find things that you want to solve. Right now I think most of the things can be solved. And these success stories and efficiency gains demonstrate the transformative potential of blockchain technology in a more application manner. If many people read the newspaper and they say that blockchain is actually very useless, it's not mainstream adopted. These are all not true. Reason being is a lot of this blockchain technology is implemented on the back end. Who is going to talk about it? Like today's context, who is going to tell you that we are using the GSM telephone system? Nobody is going to tell you this, right? These are things that are really at the back end. There's no need to spend too much time talking about it. It is the application that is the most important. The implementation of the blockchain has shown tangible benefits in terms of cost saving, efficiency, improvements, enhanced trust. These are all, sorry, something happened. But these are things that happen. I think the table is not short. Blockchain technology. So I like to really summarize everything in one piece of diagram. There are countless of all these diagrams online, but I felt that this particular one is actually very, very straightforward. So they tell you what is blockchain, right? So today, if you go back to the ministry, within your technology family, you tell them what is blockchain. You see the picture is there. How does it work? Straightforward. Request, transact, validate, block, creation of a block, attach to a block, and then it's completed, right? These are all the chain of how the technology is going to work. And then the potential applications, there's a cryptocurrency, there's voting system, there's a healthcare. Again, I think I will share some more case study at the end. But voting system is also very straightforward. It's done in many different countries, different states. They use the blockchain technology to push their voting agenda. Because in some countries you can buy your votes, right? You can go around buying your votes, pay people more money, pay some foreign workers more money, you can get the votes. But if you do it on blockchain, a lot of these things are all validated. So they can't just do this on your behalf. It's going to be very troublesome and to use too much time, right? Last but not least, the unknown and the benefits are all clearly mentioned on this PowerPoint itself. This gives you a good overview on how the blockchain technology is like, how the structure is going to look like, the main structure and the main build, how it's going to be like. These are all here. Okay, this seems like my last slide for this session. If you have any question, feel free to ping me. I'm very happy to answer questions. Like I mentioned in the very beginning, I'm not here to do a one-way communication where I tell you what is blockchain. That is not going to be very useful. The session we had yesterday, where we zoomed into things that we want to change, things that we want to look into and how we can use blockchain to solve them, I think that kind of session would be very useful. You know, we will do more of that, but with that, this is where I'm going to end. Thanks.
Thank you.